Good day. Welcome back to my training series entitled Understanding EMV. This is now the 24th video in the series, and in this section we are dealing with the EMV transaction under the EMV acquiring section. In this video we will be looking at step 12 of the EMV transaction. Okay, so let's get straight into it. Okay, so first let's just do a recap of where we are. Remember the scenario, we had Bob at the shop looking to buy a pair of socks. The teller asked him, Mr. Bob, how would you like to pay for your purchase? To which he responded, I'd like to pay with my card. He then inserts the card into the terminal, and obviously at this point we know that the technology selection was EMV, right? Okay, so once the chip has been inserted into the device, the chip has been powered up by the terminal. We then went through a phase of application selection. Bob's card had two applications or two virtual cards on the physical plastic, and we decided, after the candidate list was built and presented, we decided that we're going to use the primary application, which is a credit card. Once this was identified, the selected application and the terminal, started having a conversation, and they started exchanging relevant pieces of information. We then went through a phase of CAM or offline data authentication, where the terminal underwent certain processes like SDA, DDA, or CDA in order to verify that the card is authentic. It's not an attempted counterfeit. Once this was successful, there was a process to establish, is this transaction valid? Is it valid for geographic purposes, or it is valid for goods or purchases, etc., based on what the card product has been set up to allow. Excuse me. Once we've established that the transaction was valid, we then went into a phase where we verified that the cardholder, Bob being the cardholder in this case, is actually the authorized person attempting to use the card, right? And obviously we spoke about the various CVA methodologies that could be used to verify the cardholder. Once we had verified Bob through use of a PIN, there was then a phase called terminal risk management, where the terminal had a look at all of the conditions present in the transaction from its perspective. Okay, you'll remember that it would compare the TVR against the IACs, but basically this is the viewpoint of everything in the transaction from the terminal's perspective, right? And as a result of this, we went into step 8, which is terminal action analysis. And in this phase, this is where the terminal makes a suggestion, where it says, Mrs. Card, as part of my terminal risk management, I believe that we should, either decline the transaction or go online, or approve the transaction offline. Excuse me. Once this was done, the card did its own card action analysis, and in this phase, it made a decision in terms of how it would like the transaction to proceed. And the options obviously were the card could decide to either approve the transaction, which is a TC, or decline it offline, right? But in our scenario, we actually opted for the card to generate an ARPC, which was an indication or a decision to send the transaction online for the issuer host to have some input into the transaction. So in the previous video, we discussed what happened. The ISO 8583 message was constructed by the terminal. It was sent to the issuer host. The issuer host did some verification and validation on its side, and it made a decision based on various factors. And once it had made a decision, it would then send a response message back down to the terminal in the form of an ISO 8583 message, and this ISO 8583 message would contain the outcome of the issue decision, right? So this is where we had stopped in the last video. So In today's video, we're looking at step 12, which is the second gen AC phase of the transaction. Excuse me. Okay, so as we've just discussed, at this point in the transaction, the issuer response has returned to the terminal, right? So historically, if you look at the magstripe world, this would be the end of it. The terminal would receive the issuer host response. So let's assume that the issuer host response said let's decline the transaction. The terminal would have no further input, and obviously the card wouldn't, because the card is no longer present, once it's been swiped through. So at this point, whatever the issuer decision was would have been the final outcome of this transaction, right? So in the example I just used now, had the issuer host responded with a decline, then the transaction would have declined, right? The terminal would not have impacted or affected the transaction in any way. It would just have conveyed the issuer decision, at that point in time to the transaction. Okay. Now in the EMV world, this is no longer the case, right? So remember Order 66. In an EMV transaction, the card is the final decision maker. All right. So yes, even though we've received an issuer response back from the issuer host, it still needs to be vetted by the card, and the card will make that final decision. Right. Okay. So we now go through two steps here, right? One is a step done by the terminal, and one is the one done by the card before the transaction outcome is finalized. So let's look at what the terminal needs to do now. So the terminal, obviously, we said it receives the response back from the host system, right? It will then look at the ARC, right? The authorization response code. Remember, we said this is usually sent down in field 39 of the transaction response message. Okay, and the terminal will basically say, okay, the issuer host has indicated that we should approve the transaction, and so just based on what the issuer host has responded, the terminal will now make a request to the card or suggestions to the card that we should complete the transaction accordingly. So let's assume that the issuer host said let's approve the transaction. The terminal won't do any further risk management or anything like that. Right? It will just take the issue decision, and it will then tell the card, based on what the issuer host has told me, I now request that you generate a TC, an approval, right? The terminal will pass the request to the card, and along with the ARC, and it will also send back the ARPC. Remember, in the previous video, we said that the ARQC is validated by the host system, and then the host system will generate an ARPC. This ARPC is then sent back, and so the terminal needs to pass the ARPC to the card, right? And at this point, had the issuer host included any scripts, issuer scripts, that it wanted to be applied to the card, the terminal would need to pass it on to the card as well. Okay, so basically the terminal will pass back the issuer decision, it'll pass back the ARPC, the actual cryptogram, and it'll pass through any issuer scripts that it receives from the issuer host system. The terminal is not allowed to change or modify any of this information, right? So whatever it receives on that ISO 8583 response message, it needs to pass it down to the card, untampered with and unmodified in any way. Right. So as we said, let's assume in our example that the issuer host had responded with an ARC value of 00, which indicates an approval. The terminal will therefore request a TC cryptogram from the card. Okay. Let's look at what the card needs to do now as part of second gen AC. So the card will now undergoes a second round of card risk management before it generates the second and final application cryptogram. Okay, so it's obviously aware of the terminal request to do a TC, and remember, as in every single EMV transaction, the golden rule applies, right? So the strictest rule applies. We will try to find a reason to decline before we will try to approve it. Okay, so in second gen AC, unlike first gen AC, right, the card may only respond with a TC or an AAC, right? So an approval or decline. It cannot come back with an ARQC or a decision to go online, because obviously we've just come back from online. We've gotten the issuer host decision. There's no need for us to go online again to get any additional information from the issuer host, right? Excuse me. However, before the card makes a final decision, it first needs to authenticate that the response it received was actually sent by the issuer host, right? And it wasn't intercepted, by some hacker sitting in his basement, right? And so what we're saying in our example is the card says, okay, the terminal has received an approval from an ostensibly an issuer host, and it's asked me to do an approval. But before I, as the card, can approve this transaction, I first have to make sure that that approval that we received actually did emanate from a genuine issuer, right? And it's not someone hacking the system and telling the terminal to request a TC or an approval from me. So in order to do this, the card will process online mutual authentication leg 2, right? Also known as issue authentication, also known as ARPC validation. And in this leg, in ARPC validation, the card authenticates that the issuer is genuine, and it does this by validating that the ARPC is correct, accurate. Okay, so let's talk a bit about ARPC validation or online mutual authentication leg 2. Remember, in first gen AC, we had generated an ARQC, and obviously the card had stored it in memory. And obviously, the ARQC had been sent upstream by the terminal on the ISO 8583 authorization request message. And so, for the purpose of our example, let's assume that our ARQC value is this, right? When the issuer host responds to the authorization request, but obviously with an authorization response, in that authorization response, we would receive the ARPC, which we know the issuer host had created, right? As per the previous video, right? Excuse me. So we've got an issuer ARPC and ARPC created by the issuer host, and then here's the value, right? Also in the message, remember we said that the issuer host system generates an authorization decision or an authorization response code, okay? In our case, it's a 00, which indicates that the issuer wishes to approve the transaction, right? So what the card now has is it has an ARQC that it generated originally, and it has an issuer decision of 00 that it just received on the response, right? What the card will now do is it will generate its own ARPC. So it will combine the ARQC with the ARC, encrypt it using the DK auth key, and the output of this is actually ARPC. Now what the card will do is it will compare the ARPC that it received from the issuer host against the ARPC that it just calculated now. If the two match, in business, it means that the response message, the approval that we had received has actually come from the genuine card issuer host system. Obviously, there's a mismatch. That means that something is wrong, and there's a possibility that the transaction was intercepted, by someone with malicious intent, and they attempted to create an ARPC, which obviously wouldn't match because they don't have access to these keys. Okay, so if the calculated ARPC is not equal to the received ARPC, then the card will issue a decline, an AAC, right? It will decline the transaction. Okay, and the reason for this is that the response was received from an untrusted source. If the calculated ARPC is equal to the received ARPC, okay, then we've proven that whoever created ARPC had access to the keys, which meant it had to be the genuine issuer, and therefore the card, in this example where we said that the ARC was an approval, so then the card will issue a TC and approve the transaction. Okay, so let's just have a look a little bit at the conversation between the terminal and the card during second gen AC. So you'll see the card, sorry, the terminal issues the second command to generate application cryptogram. It says AGAE40. So what it says is, I think we should approve this transaction, right? Because that's what the issuer host told us to do, right? It then also supplies the authorization response code, the ARC. Remember we said it's a 00. Okay, so that is an approval. Okay, and obviously there's some other EMV data in there. The card now responds to the terminal like this in second gen AC. You'll see that there are multiple tags included here. But if I just expand this a bit further, so if you analyze what's given there, what you can actually see is that what you want to see is this value of 9F270140, right? So the card response of 40 matches the terminal request of 40, and it's done this because it has taken the authorization response code, it's created the ARPC, and it's matched it to this, right? And so the outcome of this transaction is a transaction certificate, right? A TC or an approval. Okay, so there's your AC, and there's your value there, right? Yeah, and already the IC just confirmed that it successfully processed what it needed to process as part of second gen AC. So second gen AC was successful, and the outcome was an approval or TC. Okay, so at this point, what we have is the final authorization outcome for the transaction. Okay, before we actually end the transaction, what will happen is that if the issuer host has sent back any issuer scripts for the card to process, okay, it will now process them before it ends the transaction. Okay, there's also something called card status updates, or CSU, that could also be present in the transaction response, and if any processing is required, that the card will do this before it finalizes or completes the transaction. So I think this brings us to the end of the 12th step. In the next video, we'll go into the 13th step, and we'll talk a little bit about issuer script processing and touch a little bit on card status updates. Okay, so we finished with step 12, and yeah, next video will be script processing, step 13 of the EMV transaction. Thank you for spending the time with me, and I look forward to catching you guys in my next video. Cheers, everyone, and have a nice day.